All right, hello and welcome to AWS Made Easy, episode number 68. And this is the show where we have guests from AWS, we review and rate AWS articles, and most importantly, we interact with you. We keep each other informed and up to date, up to speed as a community. I'm Stephen Barr. This is Rahul Subramaniam.
Hey everyone, great to be here.
Oh, isn't it? It's been a really, really nice couple of days. How's your week been?
Week has been pretty hectic and crazy, and I wish I had 2 more weekends. But it was a fun weekend. Lots of 3D printing stuff. I now have both of my 3D printers kind of printing nonstop, so that was keeping me busy over the weekend with a bunch of random prints. But I was just trying to keep up with all the stuff that is going on in the AI world over the weekend. And there is just so much happening. It's a very, very exciting space right now.
Absolutely, there is a lot going on. I watched Darko's stream yesterday, the Build on Gen AI stream, and they were talking about llama models and llama recipes. And that's just one of several classes of models now that we need to be aware of, be informed about, and it was exciting to watch them build in person.
Absolutely. There's actually a very interesting, Stephen, I'm going to post this article. You might want to just bring this one up.
Okay.
If you want to keep up with all the stuff that's happening, Sequoia Capital just published an interesting landscape of a bunch of new AI tools, and we will have it right here. This one is pretty interesting. If you go all the way down, there's an interesting landscape. Now, I'm not much of a fan of landscape, seeing how the CNCF landscape has turned out. But I think this is useful for this stage of where all the AI tools are kind of literally changing every single week. And it's good that someone has taken the effort to put this all together. I've been trying out a bunch of these tools, playing around with them, understanding their capabilities, and trying to figure out how we can really leverage them to do things more efficiently.
Yeah, it's really interesting. All of the attention goes into on the kind of consumer news and the prosumer side, Chat GPT. Then zooming out, it's such a much bigger landscape than that. And good thing, right? There's lots of different special purpose AIs that are evolving to handle very specific problems.
Correct. And even in the generic models, I mean, you've got Anthropic doing a bunch of very, very interesting work. You've got Meta doing all the work around Llama. In fact, AWS just announced a strategic partnership with Anthropic, to where they would be investing over $4 billion, I believe.
Here it is. I'll put
on
the article in
generative
the
AI models to be available on Bedrock.
Yeah, Anthropic selects AWS as its primary cloud provider and will train and deploy its future foundation models on AWS Trainium and Inferentia chips.
Correct.
Excuse me. So, if you see a little bit more contention for those chips, there you go.
And they've actually announced an investment of $4 billion into this stuff. So it's pretty amazing. Massive, massive amounts of investment going in to these.
That buys a lot of silicon.
Correct.
Yeah, this is really, really exciting. I thought Matt Wood, he is the VP of machine learning at AWS. He had a really good LinkedIn post on this that summarized it well. So AWS is the primary cloud provider for mission critical workloads, access to compute infrastructure for Trainium and Inferentium. Okay, there we go. Secure model customization for Claude, which is one of the Anthropic models on Bedrock.
Correct.
And this is really good because this allows enterprises to build on these models as take something pre-trained, so they don't have to spend weeks and weeks or months and months training something from scratch, but take something pre-trained and then add proprietary data, but then not make sure that proprietary data gets vacuumed into the next round of training, right? There's people who are worried that if you ask a question into Chat GPT, of course they're going to use that data as a feedback and reinforcement mechanism for the next round. And so if you're
correct,
you shouldn't ask important questions with proprietary data into Chat GPT.
Yes. And so doing all of this on Bedrock is kind of the way to go. And there's so much work happening. It's just fascinating. So yeah, right now I'm just trying to stay on top of all the new happenings every week in the world of AI. I think it's very transformative in the way we do all our work these days.
Absolutely.
Okay. How about
We had
you? How was your weekend?
really good. Same thing. I wish it was longer. We transitioned though from the beautiful tail end of summer into just the nice cold and rainy bit in Seattle. And maybe we're just weird here, but I think everyone's just so happy to have the cold and the rain. It's a really nice
Really?
part of it's a nice part of the year. You know, it's a bit more snug and there's board games, and we'll still have the occasional nice sunny day, you know, into October. But just, you know, it's just part of that transition of seasons, and I think everyone's kind of happy for the change. It is funny, and one of my kids was saying it makes you really appreciate the sunny days that you do have because they're finite. But
No,
that's
I
not going
can
to
quite
stop us from
imagine that.
going outside and having fun.
Oh,
Oh,
that's awesome.
and then I did. Let's see. I finally replaced my phone. I think I said a couple episodes ago. I took my phone swimming and accidentally broke the clip to my waterproof case. I want to take an analogy from that and say, okay, if you have mission critical workloads, or not mission critical, but important workloads, look at your single points of failure. And in this case, my single point of failure was a $5 lanyard that broke at the exact wrong time. So got to replace a phone. That was good. Oh, and we're preparing for tonight. There is the AWS meetup in Seattle. Let me post the link to that. There's a meetup group called AWS Seattle meetup. But let's put AWS Users Group Seattle. I'll put the page up on the screen. 1 second here. So if you are in the Seattle area, I will be talking tonight about our favorite topic, cost optimization. There it is. The AWS Seattle users group. Here is it's an admin view. Here you go. Okay, meetup.com. I will post the meetup.com link here. Automating AWS cost savings. So this is going to be a really fun talk. We're going to go through how to use the cost and usage report, how to automatically, well, like we talk about all the time, automatically realize cost savings and things that are really straightforward, like S3 intelligent tiering, like GP2 to GP3, that sort of thing. I think it's going to be a really good time. Hopefully, we'll have a good crowd. There'll be some pizza. So, hope you can make it
I
if you're
agree.
in the Seattle area. Other one that's coming up, we have a live stream with Darko and Steph and several others. Let me pull this one up. And this is on the 28th. This is the cost optimization live stream. Let me see if I can find it. And that's going to be in Portland. So we're looking forward to that one. Okay, here we go. The unveiling secrets to optimize your cloud spending. Let me
Great. Can
post
we put it up on the screen?
Yeah, let me post
Let's
this
put it up
now. Here we go.
so everyone can see.
This is the cloud cost whisperer, and Steph and Darko put together an awesome preview post. Here they are. This is the Build on Live cost optimization session. This is happening on Thursday and live from the AWS Portland studios. So looking forward to that one too.
That sounds amazing. I think I'm going to take a cue from you guys and start the AWS users group, at least in Chennai to start with. We have a very, very large AWS customer base right here. So if there is one and you're listening to this, please let me know. I would love to join. I'd love to contribute there. And if not, I'd be happy to start one. This should be fun.
Yeah, absolutely. Their meetups are awesome, and now it's one of those things you kind of almost forgot about during all of COVID. You think, okay, we can actually meet up in person whenever we want, and we can do all this stuff. And so now that we have meetups, and I think that they did lose a bit of momentum over the last 2 or 3 years, but they're slowly picking back up. And they're a great way of meeting other people in other industries, in adjacent industries, and having these really good conversations, seeing what other people are doing. And so, yeah, if you're in Seattle or Chennai or anywhere in between, join your local meetups. They're a great thing to participate in.
Absolutely. Okay, so what do we have in store for today's show, Stephen?
All right. Well, the first thing I wanted to talk about, I was kind of doing some reflecting on the episode we had with Rick that was the week before last on the GPU compute optimizer. That was really, really fun. I wanted to show a quick recap of that, and we have an announcement kind of similar we're not similar. We have an announcement that's kind of building on that. So let me show a quick recap of the show.
We picked the G4DN and P3 instances to start with. And so that's not all of the GPU instances that AWS has. We started with these two because we talked to very specific customers that asked us for this support. And so we start small and expand our 10 stakes from there, really, and prove out the ability to do right sizing on GPU instances. Also note, some GPU families only have one instance size. So right sizing isn't really something we can do on them. We intentionally keep the right sizing recommendations in the same instance family. So what you're going to see here with this announcement is support for the G4DN and P3. What that means is if you go into Compute Optimizer and you have G4DN or P3 instances in your environments, you will immediately see recommendations to size them correctly. That's exciting because GPU instances are very powerful and they can be a little bit on the higher end of the price range of instance choices to pick from. What'll happen by default is you'll see those recommendations, but the recommendations will kind of be like the currently existing recommendations where they're going to recommend size changes for CPU, memory, disk, network, and so on. But if you install the NVIDIA driver, the new metrics we're using to make right size recommendation, utilization, memory usage, encoder information, and temperature. So what we're doing is our machine learning model is looking at all of these different data sets, and we used all these data sets across quite a few number of instances to train our model on proper sizing of these resources. So if you turn on the NVIDIA agent, that ML model will then run and provide right sizing recommendations also to change the amount of GPU capacity you have.
Cool. So that was our episode, for a highlight of our episode with Rick Ox announcing the GPU cost, GPU support, GPU right sizing support for Cost Optimizer. And Rahul, can you share with us kind of our news building on that?
Yeah. So I'm super happy to announce that over the weekend, Cloudfix released the new Finder fixtures for the GPU-based optimization. We use the recommendations that come out of the AWS Compute Optimizer and allow our customers to very quickly right size and get to the most optimal or efficient instance types within those GPU instances as well. We also have a bunch of other right sizing recommendations that have already been on for a while. In particular, a shout out to the AMD recommendations, where in a number of cases we find that the 6th generation AMD instances are actually way more performant from a price and performance standpoint. And so whenever the AWS Compute Optimizer makes those recommendations, those are there to be taken up, and you can very easily and quickly save 10 to 15% on your EC2 compute cost. Now, these are fixes where we worked very closely with the AMD team to construct the methodology for how these should be safely migrated over. So if you haven't tried this out yet, sign up for Cloudfix and you can see how easy it is to migrate these instances over to the most cost-efficient instance types, or instance sizes, rather.
It was really interesting learning about the ins and outs of Compute Optimizer, and back to the GPU side, the different factors that it takes into account. I want to play one more quick little clip from Rick that really illuminated some of my understanding about how GPUs are a bit different than CPUs in terms of how you want to optimize. So give me one more second.
You are running an ML workload. You're generally maxing out that GPU, 100% utilization for as long as it takes to run the job. And that's sort of expected. And that doesn't mean that you are bogging down on performance in the same way that if CPU was 100% for 6 hours, your machine would be on fire and your app would be going down in flames, right?
Correct.
So right sizing GPUs is different, right? Because we like 100% utilization. We're happy with 100% utilization. So we apply different thinking and different model approaches to how to right size GPU instances because we understand that 100% utilization is a happy place to be in. What is not happy is very low utilization consistently over a period of time.
So I really liked what Rick said there. It really cemented in this understanding of, okay, with GPUs, you want the 100% utilization on the GPU, whereas CPU happy is 20 to 30 on average, and then bumping up to 70 to 100 on demand, but then going back to that 20 to 30%.
Yeah.
Whereas GPU, they're built for that 100% utilization to be pegged to the limit, and only when they're at that for a very extended period of time will they recommend upsizing GPU instances. Because I wanted to say a huge thank you to Rick. It was really nice having him on there. And the takeaways that I got from him are, number one, just the competence of him and also kind of the team that he represents. If you want someone to optimize your compute and see the thought and detail that AWS is putting into Compute Optimizer to make sure that they don't affect performance but can still reduce costs, have a look at our episodes with Rick, the episode 66 and our GPU special it's called 66 and a half. It was a midweek special.
Yeah.
Have a look at that.
Yeah, I think you said it right. It was amazing, and thanks, Rick, for coming twice on the show within a week. But this was important to share with the audience, so we're very, very grateful that you came on the show. But yeah, I mean, the sheer thought process and the technical diligence that goes into figuring out what is the most safe way of executing an optimization or a right-sizing optimization in particular. I think it's incredible the work that the AWS team has put in to create this recommendation. And if you haven't looked at it, if you haven't seen it, one, I would recommend go and watch the show, episode 66 and 66 and a half, as Stephen said. Watch those two episodes so that you really understand the nitty-gritty details of how the decisions are made by the Compute Optimizer. And second, look at those recommendations for your setup. I think one of the things that we shared, or Rick shared in an earlier episode, was the fact that the average utilization that we see is in the single digits, usually across customers, average CPU utilization. So there is a phenomenal amount of waste that's already in there and baked into the way people are using EC2 instances. So if you could right-size these instances, you actually stand to gain a lot in terms of efficiency. Okay, these CPUs can very comfortably operate at 50% utilization, and 50% would be a very, very high standard for resource utilization on CPUs, right? We are nowhere even close to that. So I think let's make it a target to get to at least 50% utilization. That'd be amazing, and an immense amount of money saved that we can then utilize to do other interesting things.
Yep, we are putting together a playlist of shorts and highlights, working with Rick behind the scenes. We're just about finished with those. We're getting together a YouTube playlist. So if you don't have time to watch the full hour or hour and a half, we've got some condensed versions that you can look at and kind of see the Reader's Digest, the core of the message, which is, like you said, Rahul, how this works, what are the optimal utilization targets, how to implement it. And the other thing I got from Rick, which I really appreciated, was he really cares about cost optimization, right? It's not some long ploy by AWS to get money out of you. He really, really cares about the customer. That's why he came over to AWS. I loved his story about how he talked to his interviewer about that to make sure that everyone was on the same page about why is AWS supporting cost optimization efforts. And it's because of that customer optimization leadership principle. And to see that,
and I think
alignment.
we can say that about everyone who's been on the show from AWS. They've all been amazing. They've all been incredibly passionate about saving or helping customers be efficient, helping customers do the most with AWS in the most effective manner possible. So I think all of them have been incredible from that standpoint. And I love it when an entire organization the size of AWS, where every single person is, has the same conviction about those leadership principles. It's pretty amazing, the org that has been built over there.
Yeah, they truly have been internalized. You can see that's really, really a neat thing to see. All right, well, should we have a look? We talked about GPUs. We talked about Anthropic. Let's talk about ECS. Let's put this on screen. I wanted to talk about the ECS Scalability Guide. Let's put this here. One moment here. Here we go. ECS Scalability Best Practices. This is a hot off the presses, to use an old analogy, document by Nathan Peck. And great shout out to Nathan. He was one of our first guests. So if you want to see what we were like when we just got started. He was literally our episode number
Episode
9.
9. Wow.
Look at that. So I will put
That is
this
over a year
in the
ago.
chat. So if you want to see some what experience versus inexperience looks like, go to episode 9. But Nathan had some awesome content. It was really, really, really fun. We talked about CDKs and serverless. And so now looking at this document, this ECS scalability best practices, what I really appreciate about this document is this first section, mindset. Because it's so easy to dive right into the tech and say, okay, here's the specs and the numbers and the API calls and whatever. But to actually say, okay, here's how we're thinking about it so we can get on the same page and contextualize it. That's what I really appreciate about this. And that's kind of a hallmark of really great teaching, is to give that larger context. So I really appreciate that education-based focus in Nathan's article here.
Yeah, I think this mindset is absolutely spot on, because I see a lot of folks who come in from their old data center on-premise mindset, where when you talk about scaling, you think about vertical scaling, where you basically are adding more CPUs and more memory and getting larger and larger instances to kind of take care of whatever capacity requirements are. The other part of the mindset is that you try to forecast your max capacity and then you forget about it. It's like a one-time exercise that is required to engage in a procurement exercise of hardware. And at the end of it, you kind of forget about it, everything that you do there. However, when you come to the cloud is all about starting small and being able to seamlessly and elastically grow to whatever the demands are for that particular minute or that particular hour. And it's a very, very different way of thinking about how you architect your applications and architect how your EC2 instances have to work to support that.
No, I love what you said about sometimes you do it once and then you forget about it. It reminds me of a story my friend told, and she was learning how to cook from her mom, and she was looking the recipe for a roast, and she told me that she always cut off the last inch of the roast, and she could not figure out this step in the recipe. And so finally she asked her mom and said, I did everything you told me to, but I cannot figure out why you're cutting off the last inch of the roast. And she said, oh, well, the butcher made 10-inch roast and I only had 9-inch pan. Right? And so you think, sometimes the constraints no longer apply. And you have to think, why am I doing it this way? Was that a one-shot optimization deal that then no longer applies? Let's continuously optimize, continuously reevaluate what our constraints are, and maybe they're not binding anymore.
Exactly. Yeah, so there's a completely different way you need to think about the cloud in general. And as a derivative of that, the way you think about scaling up your services. So very, very neat article. If you haven't checked it out, please do. Lots of very, very neat insights in here.
Yeah, I love the visuals, the idea of application contention. I was just looking at this one of fitting multiple containerized applications in order to maximize usage. And speaking about that 50% utilization target, right? It's right there in this visualization. So yeah, this is a great, very thorough article from Nathan. If you are in containers, definitely have a look at this. There's a lot of great visualization. And the containers on AWS.com resource, it's really good. So yeah, have a look at this article, and thanks, Nathan. I think I might be sending you an email. Maybe we can have a deeper dive into this document. I think there's a lot here, and hopefully we've come a long way since episode 9 as well. So we'd love to give you another interview with you and kind of learn from you. That would be really, really nice. So I'll be reaching out.
I think we need also an OR specialist. So I've been fascinated by the bin packing algorithms that go into these services like ECS. On one hand, you have constraint. I mean, you would think that the larger the instance type that you have, the better it is from a utilization standpoint, because you can pack all kinds of heterogeneous services onto those instances. And that's pretty neat. However, There are other constraints that get in once you have very, very large instances. Number one is if you're packing hundreds of containers, which is hard to get. But if you do end up packing more than 100 containers, then when a server goes down, you need to basically load up all of those images again and then launch them all back, if you have a large number of heterogeneous workloads running on the same instance. So I'm fascinated by the algorithm that determines what the right size of the instances that run all these containers should be. And second, how do they allocate the workloads so that even if a node goes down, it's really easy to bring back up all of the instances very quickly.
Yeah, absolutely. That's and it's not just with ECS, but also thinking about Carpenter, right? Which is doing a similar thing of how do you fit these. I mean, it's almost like Tetris, right? You've got this certain shapes that you're trying to put together just right so that you optimally utilize your instance. But then, unlike Tetris, sometimes the board can shift shape or things can vanish on you, and you need to re-Tetris all your pieces.
Correct.
Well, how do we rate this article?
Okay, this one is extremely illustrative. I would give this a solid 4.5.
I'll go 4.5. This is
very, very neat,
and definitely simplifies. This is a big simplifies.
Definitely simplifies.
This is great, and it has an educational mindset the whole way through. This is great. So thanks, Nathan.
I agree. Thanks, Nathan.
All right,
and we'd love to have you back on the show to talk through all of this and all the amazing stuff that you guys have been working on.
Yeah, absolutely. I will check out your inbox. I'll be bugging you. All right. Let's check out the RDS X2 IEDN. Does this set the record for longest instance name?
Possibly. I was confused. So the X series were originally created, the X1 and the X2 were originally created for the SAP HANA workloads because they had tons of memory, they had tons of CPUs attached to those instances to run HANA workloads. But since then, they have kind of scaled up to get to other services like databases. Now, if you are familiar with SQL Server, the licensing kind of works on a per core basis. And so ideally, you want the biggest, baddest machines with as much memory as you possibly can have so that you can load up those instances, use the minimum or use the optimal set of cores to service that. So this new instance type, which has memory going all the way up to 4 terabytes.
Yeah,
is what you need. And SQL Server, you can basically run it as a multi-tenant system. You can run multiple different schemas on the same set of cores. And it's a neat way to optimize on your licensing costs. I think we discussed it in the show with Rick.
Yeah, here we go. Compute optimizer.
The licensing cost, correct. So the licensing cost on these SQL Server instances is about 3 times the cost of the instance itself. And so you want to make sure that you are spending as little as possible on those licenses. And even if that means that you're buying a bigger machine, you're moving on to a bigger machine, I think the economics work out where net you'll actually be saving tons of money.
Yeah, that makes perfect sense. So you use, again, Compute Optimizer to optimize your SQL Server costs, and then with these big X4 IEDN instances right there, especially as you get into the heavier duty ones with 4 terabytes of RAM and 100 gigabit network connectivity, you want to be cautious about, you don't want to leave a fleet of these on overnight by mistake.
Correct.
Let's look at the article. Yeah. Let's see, 3rd generation Xeon Scalable, high performance enterprise class databases. What was so the SAP HANA one? They also had the 112X large, right?
Yeah, those are the X132X large and the X2 extra large.
Oh, here there's the U-12TB. So this is the 12 terabyte of RAM one. That's 100. Oh, look at this one, the 24 TB for $218 an hour with 24 terabytes of RAM. So this is when you want to load an entire database into memory,
Correct.
have it not touch the disk, be very responsive. And just thinking
I
about
am so outdated with all these instance types. I think there are, 600 plus?
693 in US East
693.
1. Wow.
You're getting to 700 instance types. Yeah, it's getting pretty hard to keep up with all the different instance types. And X2IEDN, like, I don't even know how to remember these instance types.
I wish they gave us a mnemonic, right? Like obviously G for Graviton,
Yeah.
A for AMD, IEDN. Does that mean they should have given us like a what are those letters for? Is it intensive enterprise
So
data?
I was usually for IOPS
Okay.
optimized whenever they used to have those. D was, so they started with the Ds particularly for the Redshift instances.
Okay,
This
so
is
database.
Actually, the database the D comes in when you have the database in there. You're right. N, I'm not sure. Is it on the Nitro platform? I don't know.
And probably E for enterprise. Well, I mean, it's all enterprise. So
It's all enterprise, yeah.
Well, I guess
I wonder whether they have
enterprise class
newer
data.
EINs, whether they have, ENIs, the network interfaces. They might actually give you more network interfaces on those instances. Maybe that's the E. I don't know. If anyone in the audience understands this, let us know. Please post your comments. Else, we will have someone from AWS help us with understanding the nomenclature of these instance types.
Okay, this is interesting. So when they introduce these, there's the IDN and the IEDN. And so let's see.
E is for EDA workloads? No.
X2 IDN and X2 IEDN both offer the 100 gigabyte.
It's networking throughput with EFS support.
Got it. Okay.
I don't know where the E comes from. There are too many E's.
All right. Well, yeah, we're gonna get to the bottom of this. We want to know. This is neat. All right. Well, how do we rate this one on the merits of the article and the announcement itself?
I think having larger databases for SQL always a plus. Simplifies licensing, simplifies costs. So I'd give it a simplifies on that front. I'm going to ding it just a tad bit because the sheer volume and scale and nomenclature of the instance types is a little convoluted and complicated. But I think in the grand scheme of things, it definitely simplifies things. And then I think the article is pretty simple and straightforward. So I would give this a 4, solid 4.
There we go. 4 clouds. All right. Well, before we move on to the next article, I wanted to quickly talk about what's coming up in 2 months. reInvent.
Wow.
2 months? 2 months is the time. I got my reInvent hoodie on from last year. So reInvent, there's some really good stuff coming up. So first of all, we talked about Compute Optimizer. There's Rick's session, COP204. So
yeah, please check that out. It's going to be really, really important. And we believe that there would be some very interesting announcements to be made. So don't miss out.
Yep. Go to COP204. Then we've got some sessions. Ooh, okay. That's ticker tape. All right. I like the title of Saving Too Much on AWS. If not, what are you waiting for? So
Correct.
The first one, what's saving too much? Do you think people are saving too much?
If someone is saving too much, I would love to speak to them. Like, I would love to pick their brain about all the things that they're doing. So yeah, they should be on stage talking about all the amazing stuff that they're doing if they truly believe that they're saving too much. Though I think all of us are trying to figure out the optimal way to operate. So I think most of this talk is basically going to be about how you can get started with savings right away, not have to wait for these grand plans and grand programs that you create within the organization. One of the things that I see very often, especially in large enterprises, that you create these FinOps orgs and you create these committees that deliberate for months on a plan to start saving money, right? And I have seen those fail more often than not. And so we're bringing in our experience, a whole lot of experience from the AWS team themselves, and a lot of our friends that have contributed to the knowledge of how do you get started right away? How do you make yourself effective in starting with the savings and then build on it? Like build your savings empire. Don't start with a big bang. Don't just take the bootstrapping approach. And we have some very interesting findings and insights from all the optimizations that we've been working on for almost 15 plus years now. So we'll be sharing a lot of that during that particular talk.
We have a comment: can never save too much, especially when maximizing performance to find the optimal level to operate.
Patrick, I completely agree, Patrick.
And thank you for watching. Thank you for being here. I know you said you were on mobile, so thank you for tuning in. We really appreciate that. Other session, COP219S, a cost saving spectacular. So that's going to be.
You should talk about this on Steve.
That's going to be with myself and with Darko, with Steph. We're all going to be on stage. We're going to just be talking about cost savings. We're going to make it really, really fun. A big, how do I say it, performance approach to cost savings. So I'll leave it at that for now. We're having a meeting later in the week to kind of get some of the details ironed out, but it's going to be a blast. So hopefully we'll have a bit of a preview for you in the next couple of weeks. And then the real thing will happen, just over 2 months away. We are moving quickly.
Absolutely. If you want to watch a whole bunch of very, very fun people talk about something that's really important to everyone, don't miss out the Cost Saving Spectacular.
All right. We'll hope to see you there. Okay, next one, RDS. So let's put this on the screen. Okay, Amazon RDS Performance Insights support SQL level metrics for Amazon RDS for SQL Server. Okay, this is really interesting. This is talking about identify high frequency, long running, and stuck SQL queries in seconds.
Yeah. So this is something that has been around for a while with Redshift, with Aurora, and a bunch of other database services. And so this being extended to SQL Server is a huge deal as well, because you don't want certain queries hogging up your database. Usually, I find that when you have insights like this at a SQL level, it gives you a really good idea about how you should split up your reads and your writes, and how you can throttle some services and some accounts. You can get much better control over not having noisy neighbor problems. So a service like this really helps you make sure that you can actually run multiple schemas, you can have multiple users, all on a single instance, maximizing what you spend maximizing the efficiency of what you spend on your SQL Server licensing. You can do all of that only when you have these very granular query level insights.
And with SQL, it's really easy to write two queries that are functionally equivalent, but take orders of magnitude different time to run. I remember one place where I worked where they had Tableau, and someone was blaming Tableau for taking too long, taking a minute to render a certain dashboard. Well, it turns out the query powering that dashboard took 59 and a half seconds. So it wasn't Tableau's fault in that case. And what ended up happening was that they were doing what's called a full node scan. So if you ever end up debugging the performance of a SQL query, that's what you don't want to see. It means you are taking a field and looking at every single value of that field rather than using an index, which is a special data structure, so you can very quickly filter on that particular column. So full node scans, you can write queries and they can sneak into your queries, and that's when they start bogging down. So being able to analyze these queries and say, okay, look, this is either long running or it's stuck. Being able to see that in your CloudWatch, that's great.
Correct. So there are two tools that I have found to be fundamental whenever you're doing any database work and trying to build either performance or efficiency. The first one is, of course, your SQL Planner. It's the tool that basically helps you understand how your query is going to be translated by the engine and how different parts of it are likely to take how much time to execute. So if you're not using the query planner, especially for your big, large, hairy queries, you are kind of missing out on a very, very important factor in how you design your database. The second one is these insights about queries that take long, because irrespective of how your query planner actually executes, it depends on how you're slicing the data across the tables. How much are you reading in every subquery? How much data is going into memory? How long does that take? All of those become a factor. So by understanding which queries take the longest and then using the query plan to break it down to understand where you're spending time, you can either optimize it by having more indexes or figure out a different way. I remember in my very early days, I used to make the really terrible mistake of missing out a left join and would just do a right join. Like simple things like that could make you scan a lot more data than is absolutely necessary. So doing filtered, subsets of data that you're joining together instead of joining massive amounts of data and then filtering are some of the simple things that you kind of must learn how to fix right up front.
That same place that had the slow dashboard, they also had this issue where someone would make a view and then it would be exactly right, and someone else not wanting to change anything, good practice, take a view, build another view on top of it. And then someone's, I'll say, this is really useful, but I want this one more field, so I'm going to rejoin it against itself or rejoin it against another query. And I remember at one point there was a view that was very popular and being passed around to different analysts, and then I tried to figure out, well, what's the actual underlying table? And it was like 14 views deep. So, yeah, that's the kind of stuff that slows things down. It's very easy to have that happen and to have, especially when you only need the data once. So you build this useful dashboard, then someone else wants to build on it to update every minute. Well, those are very different use cases. So being able to identify, like I said, high frequency, long running, stuck, that's really useful. How do we rate this one?
Again, I'd give this a good 4.5 and simplifies. And I'll add one other comment, which is if you've looked at the last month of announcements around RDS, a lot of the focus has been on RDS for SQL Server. So you can imagine how much pressure AWS customers are applying on AWS to say, we are spending an insane amount of money on SQL Server, help us out. So if you are running any SQL Server workloads, there are all these amazing announcements, whether it's the compute optimizer, licensing optimization, the new instances that are available for SQL Server, and lastly, this insight to figure out which are your long-running queries, and then using the SQL Planner, of course, the query planner. These are all tools available to you to now really optimize whatever SQL Server workloads you're running yourself.
Awesome. We'll follow this space. Check out the RDS Performance Insights. This can be very helpful for you. All right, the link is in the comments. Which one should we do next? Awesome. We've got the step functions distributed map, and then we're going to talk about EBS-backed AMIs and how to have less of them. Or pay for only the ones that you need.
Why don't we talk about the step functions distributed map?
So this is what this is what's called a fan out, right? So if you have one Lambda function, which then say generates a set of parameters, say you're doing a simulation, and you have another Lambda function which runs that set of parameters, you want that second Lambda function to run in parallel. So step functions, they're like flowcharts, right? The flowcharts for chaining Lambdas and other services together. And so this distributed map, it's saying take a Lambda and then run lots of copies all at once.
Yeah, the way my mental model of this is kind of like a easier version of EMR or the map reduce operation. So in a map reduce operation, you typically have, you basically have a function that kind of needs to iterate and operate on a very, very large amounts of data. And you have the map operation, which is a simple function that operates on a particular data. It has parameters. It does something. and you want to repeat it across a massive amount of data, right? You want to repeat the same thing over and over again across massive amounts of data. So that's the map function. If you're familiar with Python maps, it's kind of that's a simplified mental model that you should have for what a map function does. And so step functions can actually allow you to do that and do that at scale. You get all the benefits of how you monitor what's executed, what's not executed, what's failed, doing retries, all of that stuff you can map out in your process with the step function. And then you can do a reduction at a later stage once you have collected all of that information. So it's incredibly useful. I think it's a simpler way to deal with map reduce kind of operations without actually having to start up an EMR cluster and then figure out how to configure it and then make sure that it's all running seamlessly. Step functions are way easier to get started with.
And thinking about limiting that blast radius, I remember a long time ago, I did a project for a professor who had that same kind of problem of running a workload in parallel lots of times. And I was responsible for making that work. And, at one point we started up, there were 6 regions at the time, and we started up 100 instances in each region, which was my quota, and have each instance had a user data script that was pulling from an SQS queue and then pushing results into S3. That was a fine architecture. It was really simple, but just being able to, with Lambdas, saying all of a sudden you have this cluster of 3,000 workers,
right,
and they will shut themselves down as soon as it's over. You don't have this massive cluster running, and you've got your configuration script wrong. That's going to really hurt, especially
Correct.
back at that time where they were rounding up to the nearest hour. So you run it for 20 seconds, realize that you messed up. Well, that's going to really hurt.
I agree.
This is a great way of limiting your blast radius while still doing massively parallel, massively concurrent applications without that worry of, wow, I'm starting up this big cluster. It's going to happen very quickly, and then just as quickly, garbage collect itself, and you're back down to a serverless, zero cost to run setup. That's really exciting.
Absolutely. So this is really neat. If you have these kind of workloads, please check out the step functions distributed map. It's really simple, really straightforward. You can write your code for the Lambda in any language you want, tie it all together beautifully in step functions. You have an amazing studio tool that you can use to actually build out visually how things kind of tie together, and you can stitch all of these services together, stitch these Lambdas together. It's really simple, really straightforward. So go check it out. I would give this a solid 4 and simplifies. I think EMR, sometimes I think of EMR as like a cannon, and sometimes you just need a fly swatter. The cannon is an overkill to swat a fly. And so you want to use the right tool for the right kind of task that you have.
Did you ever use MPI with C and try to do manual message passing between nodes in a Beowulf cluster? It was so hard to get all this stuff right. And you get all these weird timing issues, and it was so hard to get all this stuff right. And you had to boot the cluster with PXE so they'd all come up at the same time. Half the time your nodes wouldn't all come up. It's so nice to be able to think in this way of just distribute the computation, not thinking about IP addresses or memory or shared memory or all the weird stuff that comes up with concurrency, with locking and resource contention. It could just do this huge job, clean up after itself. The end.
Yeah.
That's exciting.
I think by the time I really started working with large-scale distributed systems, I was already on the Java bandwagon. So I think I avoided a lot of the low-level C pain that came with dealing with these large distributed clusters.
That's a good way of describing it. All right, we have one more. We're going to do our deep dive, and this is based on this new blog post that we have, managing EC2 costs, optimize EC2 costs by managing unused AMIs and EBS volumes. So in this one, we are talking about EBS-backed AMIs. So I'm going to just walk you through the blog post, just going to show you the core details of how it works. So you can, as with all our finder fixers, we have a finder fixer for this, but you can also implement it yourself. Or just if you're curious to see how it works before using the CloudFix finder fixer, this is how it works. So I think we had actually kind of talked about this. When you're using EC2 and you want to set up your OS, you can set up what's called an AMI. Now, initially, AMIs lived on S3, and it was a bit cumbersome to make new ones, right? They had the initial ones, and I think the original idea was that you would do all the post-processing in a script, and that's where you installed all your applications. But as EC2 became faster and you wanted to start and stop instances faster, having everything pre-configured into a custom AMI was the solution. And so then they started putting AMIs on EBS, and that happened in 2009. Okay, so here's some of the history of EC2. We cover it in this. This is Jeff in Mexico, where he launched the EC2 beta blog post in 2006. Then here we go. EBS-backed AMIs have been around since 2009, so ancient by AWS standards. Now, EBS-backed AMIs, they cost the same as any other EBS volume, so 5 cents per gigabyte per month. Now, that doesn't seem like it's too expensive, but the problem is it's really, really easy to accumulate a lot of these. And so this is what I'm showing with this table here. And Rahul, I'm sure you've seen this. So you start with your base install.
Okay. Hey, this is when AMIs had smaller names.
No, I just shortened this for
you shortened.
Yeah. So say if you're developing and you start with your base install, you make this, you have this AMI that's this size and it costs this much to carry around for a year. Okay, then you add one bit of software and it gets a bit bigger. You added a new feature, it gets a bit bigger. And you think, I want to be able to roll back to any point in time, so I'm going to keep the old ones around. You just want to keep adding these things. And before you know it, you've got this long trajectory. You've got this long history of AMIs that are sitting there, and most of them will never get used again. But you have this, in this table, it's showing, okay, you're using something that costs $16 a year, but you're carrying around $350 a year worth of charges. And so this is the situation that we want to avoid. And this often shows up via automation. So say it's really easy to make a GitHub action or any other CI automation, which makes an EBS-backed AMI as part of a build process. And that could be a really good thing, right? Because you want to be able to go back to any point in time. So this is, I put this reference in here to this Fantasia cartoon. You indulge me for 30 seconds. This is how I think about out-of-control automation, right? This is the 1940s Fantasia, where, there we go. I'll stop this here. So Mickey cast a spell on his magic broomstick to start moving buckets of water, and then he fell asleep, and then he wakes up, and there's hundreds of broomsticks moving a river's worth of water, and it floods the whole place, and Mickey gets in trouble. And that's what I think about when I think of out-of-control automation that's doing way too much, right? You have this initial idea, but the problem with automation and the benefit of automation is that it keeps going. And it's easy to accumulate a bunch of artifacts. So in this case, we are accumulating too many EBS-backed AMIs, and we don't want to pay for them. So how do we find and remove these unused AMIs? So first of all, we need a definition of unused. And so we consider an AMI unused if it's not being used for a running instance and it's not been started in the past 31 days. And so this is what we find with all the finder fixers. First, we have to come up with a definition that actually makes sense, that kind of covers all your cases. And so it could be the case that you have a very long running instance, and it is possible to delete you can delete an EBS-backed AMI that is in use by a running instance, but then you can never start that again. So don't do that. So here's what we do to find unused AMI. So it's not used by a running instance. That's where we have that criteria, and it's not started in the past 31 days. So it's also possible that you have an AMI that starts and stops frequently, or instances based on this AMI that start and stops frequently. So you have a low probability of finding one running, but it still could have been started, still could be in use. So that's where we have this definition. So our pattern here is to find all the EBS snapshots. And this one, this one I find is almost the most brute force of the ones that we have, in the sense that you need to find all the EBS snapshots, and then you're looking the other way to say what EBS snapshots are associated with AMIs, because you can have non-AMI EBS snapshots. And so you're kind of looking the other way. But this is an important thing to know about the cur, is the cur is showing you things at a billing level, not necessarily at a logical level. And so you need to supplement it with API calls in order to reconstitute the larger superstructures. In this case, which are EBS backed AMIs and which aren't. So here's a query, so you can find snapshots.
Share the screen.
Thank
bring
you.
That up.
Let's see. Let's put on the screen. Thank you. Just because I'm looking at it doesn't mean anyone else is. Okay. So here is the query to find EBS snapshots. And this is just an easy way of doing some quick math to figuring out, okay, how much does it cost? So this is annualizing it. So this is going to give you all of your EBS snapshots. And what you want to do is, of course, you have an account, region, and then the EBS snapshot identifier. So then this is what it's going to look like. It's going to give you account, region, identifier, and this public cost. And we call it public cost because if you have a savings plan or some other way of pricing snapshots, you could take that into account. But for this case, it really doesn't matter. You either do want them or you don't. Okay, so now that we have this resource ID, we want to figure out the identifier. And so this last little bit here after the slash, this is the identifier. And I put this link here for this ARN cheat sheet, which I found really useful. It shows you how to break down for every resource, how the ARNs, the pieces of information in the ARNs. And this is useful if you're constructing regular expressions to match on particular types of ARNs. Okay, so you can take your EBS identifier that you got from the cost and usage report, and you can run it into describe images, where you're looking for this particular identifier. So many times this is going to be nothing. You're going to get this. And that means, this is just a regular old EBS snapshot. It's not associated with an AMI. But if it is associated with an AMI, you're going to get this. And this is going to be a description of your AMI. So this is showing your image ID. It has a lot of really useful information. Yep. So the thing that we want to look for here is, okay, was this recently used? So unfortunately, this one doesn't give us that, but it does give us the image ID. So we've started with the snapshot ID. If it's associated with an AMI, we're going to get this image ID. And now we can query and say, was this image used recently? And so we plug that into this last launch time, AWS EC2 last launch time with this image ID. And this is going to give us this. This is our last launch time. So this is if we figure out, okay, has it been used in the last 31 days? That's what you want to check this. Is this within 31 days? So that's part one of our in-use criteria. So if this last launch time is more than 31 days ago, you might be eligible this might be inactive. We still have to check, is it running? So to do, is it running? We can use describe instances and then do this filter on image ID. So take this image ID here and you plug it in right here. And this is shaping the output and you're going to get this list. So that what this is saying is the instances that are running based on this image. And you see in this case, both the instances that were running based on this are terminated. So that's what you want to look for. Stopped isn't good enough because stopped could be restarted. So you want to make sure that everything associated with this image has been terminated and therefore cannot be restarted. So these are the two things you want to look for. If it passes these two tests, then you can go ahead and deregister the AMI. So this is really cool. There's this thing called the recycle bin policy, which you can use for EBS objects. So here we go, EBS snapshots and EBS AMIs. So since AMIs are running can be part of your infrastructure, we want to make sure that they don't get deleted until you're really sure you don't need them. So we set up this recycle bin policy so they can get deleted, but you actually have an extra 31 days to get them out of the recycle bin before they're gone for good. So we'll set the recycle bin policy, and that works by tags. So by deregister, you want to deregister an AMI. You want to tag it so that it gets picked up by the recycle bin. And you want to create the recycle bin policy, which looks for a tag. Then you want to tag the EBS snapshot that is an AMI that isn't used. Then you want to deregister it. And then once you're done with that, it'll go to the recycle bin for 31 days, and then will get archived by the archiving EBS snapshot finder fixer. This is what this looks like to create the recycle bin rule. This is what it looks like to create the tag. And then finally, this deregister command. This is the deregister image command right over here. And you just pass it an image ID, and it's going to deregister the image. Then, of course, we have the CloudFix Finder Fixer. We make sure that this all happens. And the really cool thing is it builds on an existing Finder Fixer, which is the EBS Snapshot. So once it passes out of the recycle bin, it can then get archived by the EBS Snapshotting mechanism. And there we go. You don't want to waste all of this money and all these resources holding these artifacts, these ones here. You probably don't need this one and this one and this one and this one and this one. You want to probably keep your latest one, tags of your production ones, tags of certain versions. You don't need to keep every single one that was created by your CI/CD pipeline. It's a neat idea, but this is one way of kind of cleaning up after yourself, because like we learned from Mickey and Fantasia, if you have automation, you can create a runaway set of resource consumption that will eventually make a mess.
Yeah, I agree. And actually, if automation is done right, with the right, experience and backing, and with the right information, it can actually really help you make sure that your cleanup process is accurate and it actually works the way it is supposed to. So some of these fixers, in my view, are so complicated and convoluted that you get one step wrong, you can mess up a whole lot of things. So you'd much rather rely on automation to execute them consistently and at scale. So that's something that you should really think about as you're doing this. One-off, there's one AMI or one EBS volume, sure, you can do that yourself. But when it comes to doing things at scale across your accounts, across all the regions, please use automation. Do not try to do this manually. The whole aspect of cost optimization is not a once and done exercise. You have to repeat it constantly. All of these instances will keep coming up. These AMIs will keep coming up. You want to make sure that you're on top of things consistently. And if you have to do that, automation is, in my view, the only way to go about it.
That's really, really great insight. It's the only way. You always think, okay, I can manage this, but then it quick gets out of control. We have a great question, I think, to end our show with, and this is Sarah Pepper, saying, "What is our favorite EC2 instance and why?" That is a great question.
Oh. Okay, I'll start with this one. It's more for historical reasons. So I would say my favorite one is the X132XL. And the reason is because in the early days of AWS, or when this just came out, and I think this is probably 2011, 2012, or like very early on, when they first launched the X1 instance types, I remember getting a call because I launched 100 instances. I couldn't launch 100 instances of these. And I remember getting a call from AWS saying, "Hey, what the hell are you doing by launching 100 X132XLs?" And I was like, okay, these are $12 each. I'm going to run it for an hour and just see how much capacity I can create for a large, very, very large cluster. And we were trying to run a bunch of very interesting workloads on them. But that, got me a lot of amazing discussions and connections into the EC2 team, and kind of led to a lot of the collaboration that we've had over the last 10, 15 years. So I remember the X132 XL very fondly for that reason.
Well, I would say mine, it's going to be the C7G. Just thinking about the critical mass and the momentum that when that launched, what that meant. That's really exciting. So I would definitely say the C7G and all of what it means to have a processor from the ground up that's tailored to real life workloads. So thank you, Sarah, for the question. I know on StreamYard it says LinkedIn user, but looking at the LinkedIn chat, that was Sarah Pepper, who we had on our show was 2 weeks ago now. That was a blast of an episode. That was episode
Absolutely.
67.
If you missed that one, I think we were laughing through most of that show. It was just that amazing. So yeah, thank you so much, Sarah. And
I'm working on the shorts and highlights of that one. It's that was a blast. That was on end user
100%.
computing. Oh, that was Sarah and her colleague Andrew Wood.
Okay.
All right. Well, this has been a really fun episode. There's a lot to do. Stay tuned to the CloudFix channel. We're doing more shorts and highlights, especially discussing the recent Compute Optimizer features. There's a lot of detail there. A lot of other content from our other episodes coming out too. We just posted a short of Keith Hodo talking about certifications. Recently had an interview with Alex Kearns, who's an AWS ambassador. He was in town, and we had a good sit-down discussion here. So that will be coming out in the next couple of weeks. And yeah, please stay tuned, stay in touch as we lead up to reInvent. And please ask any questions that you have. We would love interacting and just learning together. That's, I think, what keeps us here is learning together.
Absolutely. With that, thanks everyone. We'll see you next week.
Take care. Bye-bye.
Bye-bye.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry because CloudFix fixers are AWS recommended and easy to use. It's the only tool that fixes cost savings opportunities and doesn't just find them. It's the easiest way to save money on AWS. It's all 100% automatic and risk-free. And the best part is that it works non-stop. See for yourself. Click on the button to get a free demonstration of CloudFix and stop overspending on